Hello there everybody. Today I'll be showing you how to find the inverse of a 3x3 matrix. Now the reason you'd find an inverse is if you're trying to divide a matrix. So let's say we have A equals B, C, and we have a value for A and B. The way we would get C is that we do C equals A times the inverse of B. In normal linear equations we do C equals A divided by B, but you can't divide a matrix. So the way you divide a matrix is you times it by the inverse. So let's get started. So we're going to have the inverse today. We're going to start off with a very simple, just something quite simple. 1, 2, 3, 4, 5, 6. 1, 2, 3 again. And now we're going to find the inverse of this matrix. So there are several steps. The first step is we want to find the matrix of minors. Now if you don't know what the matrix of minors is, it's basically you have to imagine that you cover up. So we'll look at the top left number, which is 1. We cover up that row, which is 1, 2, 3, and we cover up that column, which is 1, 4, 1. And that leaves us with 5, 6, 2, 3. Now what we want to do is find the determinant of this 2x2 matrix that's left behind. So we do 5 times 3, which is 15, minus 6 times 2. And the way you do a determinant is AD minus BC. So we're going to do 5 times 3 minus 6 times 2. And that's going to be the top left number of our inverse. So we have 15 minus 12. So far so good. Now to get the second number in our inverse, we want to cover up the second number, which is 2. So we look at 2, we look at the column that it's in, and we look at the row that it's in. I'm just going to rub some of this out to make it a bit easier. Okay, let's start again. So we've got 1, 2, 3, 4, 5, 6, and then 1, 2, 3. So we've done the first number, which is 3. Now for the second number, we're going to cover up 2 and its column and row, which are 1, 2, 3, and 2, 5, 2. Now covering this up, this leaves us with the matrix, 2x2 matrix, 4, 6, 1, 3. Now we find the determinant of that, which is 4 times 3, which is 12, minus 6, which gives us 6. Okay, now we move on to the third number in our matrix, which is 3. Now we cover up the row and the column, so it leaves us with the matrix of 4, 5, 1, 2. Now we did the determinant. 4 times 2 is 8. 8 minus 5 is 3. And there we go. Now we have the top column of our 3x3 matrix, which is good. Now we move on to the second row. We start off with 4. We look at the row that 4 is in. We have 4, 5, 6, and the column, which is 1, 4, 1. It's going to start getting a bit messy now, but if you can just hold on. Okay. Now we've got the 2x2 matrix of 2, 3, 2, 3. So 2 times 3 is 6, minus 2 times 3, which is 6, so we get 0. I'm just going to rub out the matrix just to make things a bit easier. Okay, let's write it out again. And now we're going to repeat this process for the rest of the matrix. So I'm just going to do that, and I'll talk my method through as I do it. So the next number is 5. We cover up the column that 5's in, and we cover up the row, which leaves us with the outer corners, 1, 3, 1, 3. 1 times 3 is 3, minus 3, that's 0, so we get 0 again. And then we go over across to 6. 6, we cover up the row and we cover up the column. Now we're left with 1, 2, 1, 2. 2 minus 2 is 0. So yeah, I picked this matrix because it would be nice and easy. We'd have 3 consecutive zeros in the middle. Now we move down to the bottom row. We cover up the 1, which leaves us, and we cover up its corresponding row and column, which leaves us with 2, 3, 5, 6. 12 minus 15 is minus 3. Now we're on bottom middle. We cover up the 2, 5, 2 and the 1, 2, 3, and that leaves us with 1, 3, 4, 6. 6 minus 12 is minus 6. And now we have the last number, which is 3. We cover up the row and we cover up the column, which leaves us with 1, 2, 4, 5. 1 times 5 is 5, minus 8, minus 3. and that is the last number of our matrix. Now this is only the first step of the process. Now what we need to do is we need to find the cofactors. And what cofactors means is that we need to times the several numbers by -1. I'm going to circle these numbers now. So it's going to be top middle, left middle, right middle, and bottom middle. All these numbers are going to be times by -1. Now because I'm just going to put a negative sign in front of all of them. -0 is 0, so I'm just going to ignore that. And then -6 becomes a +6. Now we need to find the transpose of the matrix. If you do not know what transpose in the matrix is, that's just where we swap the rows and the columns. So 3 minus 6, 3, rather than being the first row, it now becomes the first column. 3 minus 6, 3. 0 stays in the middle, but now the first column is 3, 0, minus 3, and that's going to become the top row. So we get 3, 0, minus 3, and we just fill in the blanks now. 6, 0, and 6. There you have it. Now there's one very final step for this inverse matrix. And what that step is now we have to find the determinant of this 3 by 3, and we have to times that. We have to find the reciprocal of that and times it by this new matrix we found. Now usually that would be very difficult, but because we've done most of the work already, we can actually just skip a few steps. So when you find the determinant of a 3 by 3, you look at the top left number of the original, which is 1, and you times it by its corresponding 2 by 2 that leaves behind, which is 5, 6, 2, 3. But if you look at the previous step, we actually find out what the determinant of 5, 6, 2, 3 is. It's actually the top left number here. So we're going to do 1 times 3, and that's the first number, minus, now we look at the second number, which is 2, block out the row and column of 2, which leaves us with 4, 6, 1, 3. We already found out the determinant of this, which is -6. So we're going to do -2 times -6, and the second number in a determinant always has to be minused. And now we've got 3. We cover up the column and the row for 3, which leaves us with 4, 5, 1, 2. And the determinant of that is 3, which we calculated earlier on. 3 times 3 is 9, so we're going to do plus 9. And now let's just figure out what that is. So 3 plus 12 plus 9, which is 24. 3 plus 12, yep, is 24. And now let's write out our final answer. So now that we've got 24, and we've got the matrix that we've calculated before, the determinant of this is going to be 1 over 24 minus 3, 0, minus 3, minus 6, 0, 6, 3, 0, minus 3. Now actually a lot of calculators can actually calculate this for you, so if you want to double check your answer, you can just type this into your calculator and this is what you should get. But obviously the calculator will give you the expanded out version, so it'll do minus 3 over 24, which is just minus 1 over 8, which is minus 0.125, and it'll give you the whole thing in terms of decimals, but you can just simplify it and leave the fraction on the outside. So there you have it. That's how you find the inverse of a 3 by 3 matrix. It's a difficult, there's lots of steps to it, but if you just remember the basic steps, you should be fine. And the basic steps go as follow. First, find the matrix of minors. So this is blocking out the column and the row and then finding the determinant. Second step is you do the matrix of minors, and then second step is you need to find the cofactors, which is just timesing the outer middles by -1. If this is our matrix, that's what it would be. And then the last step is second to last step is find the transpose, and then times this final thing by 1 over the determinant, and that should give you your inverse matrix. So I hope you enjoyed this video. Let me know if you understand it or if you want me to explain anything in more detail. I hope you enjoyed, and remember, maths is the way.